Good evening students. Today we are going to discuss calorimetry numericals. First we will start with the formulae. First one, change in temperature delta T, whether it is in degrees Celsius or Kelvin, it will be same. Second one, conversion of degrees into Kelvin, 273 plus T. Third one, we are writing heat capacity C dash, which is equal to heat energy Q by delta T. Fourth formula, Q is equal to mass into specific heat capacity into change in temperature. Fifth one, specific heat capacity is represented as C, which is equal to heat capacity by mass, or you can also write C is equal to heat energy by mass into delta T. Then heat capacity C naught can be taken as mass into specific heat capacity, that is M into C. Heat lost by hot body is equal to heat gained by cold body, which is principle of calorimetry. M1 C1 T1 minus T, where T is equal to final temperature. So hope you have understood the formula. Now let us see question number 2. Now in page number 288, question number 2. So what is given here? They have given M is equal to 200 grams. We have to convert in kg, so we get 0.2 kg. Then specific heat capacity C is given as 410 joule into kg inverse and Kelvin inverse. They are asking what is heat capacity, so we need to calculate this. So we know the formula, that is C is equal to C dash by M. So therefore to find the C dash, cross multiply, so C dash is equal to C into M, so which is equal to 0.2 into 410, so we get 82 joule per Kelvin. Then B, we need to find out the heat energy, so you know that Q must be identified. So heat energy Q, how to find out? They have mentioned delta T. So what is delta T? Final temperature minus initial temperature, which is 10. So the formula for heat capacity is Q by delta T. So therefore on substitution we get C dash is given as 82. So from the first question we got this is equal to Q by 10. So therefore Q is equal to 82 into 10, which is 820 joule. Hope you have understood this. Next, question number 3. Here they have given mass 2 kg. C dash is 966 joule per Kelvin. Now in the first question they are asking you to identify what is Q. Here given value delta T is equal to 15 degrees Celsius. According to the formula, Q is equal to C dash into delta T. We can substitute the values, that is equal to C dash is 966, delta T is 15. So finally we get the heat energy Q is equal to 14,490 joules. Hope you have understood this. Next, second one, they are asking specific heat capacity to calculate. So the formula is C is equal to C dash by M. So we need to identify 966 divided by mass is 2 kg. So answer will be 483 joule per kg per Kelvin. Now let us take question number 4 now. So in the question number 4, they are asking to find out the heat energy. Given information, M is equal to 200 grams, nothing but we can also write it as 0.2 kgs. Now what is delta T? Final temperature minus initial temperature, so we can get it as 50 degrees Celsius. Next, Q is equal to M into C delta T. So this is the formula what we have to apply. Now first let us identify M is given, so C we have to calculate. So how do you get this? The specific heat capacity is given as is given as 390. So joule per kg per Kelvin. So that is equal to, substitute that, mass is equal to 0.2, C is equal to 390 and delta T is 50. So we get an answer 3900 joule. So this is about your question number 4. Now let us move to question number 5. Here what is mentioned, heat energy is 1300 joule, mass is given as 0.5 kg and delta T we have to find out, that is final temperature minus initial temperature, and you get 20 degrees. The question is calculate specific heat capacity, that is C we need to find out. From the formula Q is equal to M into C delta T. Q is 1300 joules, M 0.5. So we should know what is C. Delta T is 20. Now send this to other side. So therefore C is equal to 1300 by 0.5 into 20. So finally we get a C value as 130. Unit is joule per kg per Kelvin. Hope you understood fifth question. Next, question number 6. What is given? M is given as 50 kg. C is equal to 960 joule per kg per Kelvin. Change in temperature delta T is equal to final 38 minus initial 18. So we get 20 Kelvin. So heat energy we should find out, and also they gave another point, that is power is 500 watt. Right, you know the formula for power. Power is equal to heat energy by time. Heat energy by time. Next, first find out Q. Then we can substitute here Q by T, nothing but P is equal to Q by T. Right, so let us substitute the Q value as MC delta T. Mass, you know, 50 kg. Specific heat capacity 960. Delta T is 20. So we get a value of 960,000, that is 9,60,000 joule. Hope you have understood this. Next, what we need to do, we have to use this formula and substitute it as power is given as 500 watt. So this formula we are using, nothing but Q by T. So you want a T. So T is equal to Q by power, nothing but Q is 9,60,000 joule divided by, here you got 500 watt. So upon calculation, finally T we got 1920 second, and in minute you have to convert it and write it as 32 minute. You know very well, divided by 60 will give you in minute. Hope you have understood question number 6. Next, let us see question number 7. So what is given here? Power is given, similar question, 600 watt. Mass is given as 4 kg and delta T, final 15 minus initial 10 will give you 5k. Time is 100 second, and you know the formula for power. Power is equal to heat energy by T. Therefore, to get Q, we can use this formula as power into time. Hope you are able to understand this. Next, so in this they are asking you first question, that is what is the heat capacity? What is the formula for heat capacity? Q by delta T. Right, so we should know what is Q here. Power is how much? 600. Time is given as 100. Is it right? So therefore you get 60,000 joule. So Q is equal to 60,000 joule and delta T is 5. So therefore heat capacity C dash is nothing but 12,000 joule per Kelvin. Hope everyone understood this. So first question we got nothing but 12,000 joule per Kelvin. Now second question they are asking specific heat capacity C. So you know that C is equal to C dash by M, and from the previous question we found that it is 12,000, and what is mass here? 4 kg. So finally on cancellation you get 3 into 10 to the power of 3 joule per kg per Kelvin. So you get specific heat capacity. Next let us go to question number 8. So question number 8, given values, mass is 0.5 kg, specific heat capacity is 4200 joule per kg per Kelvin, delta T change in temperature, final 30 minus initial 5, you get 25 K or in degrees. Next, Q is equal to MC delta T. Applying this formula, mass 0.5 into 4200 into delta T 25. So we get heat energy as 52,500 joules. Now the question they have mentioned as the rate of extraction of heat. The rate of extraction of heat is given as 30 joules in 1 second. Now they want here what is the time for the extraction. So this is the question. So you got the value here. What is the value? 52,500. You don't know the time, so take it as x here. So on cross multiplication, what we get? 30x is equal to 52,500. Therefore x is equal to 52,500 by 30. So we get 1750 seconds. So converting into minute, finally we can write it as 29 minutes and 10 seconds. Hope you have understood question number 8. Now let's take question number 9. So what is given we will write. So on one side mass 50 grams. So you can take it as M1. This is T1 is 150 degrees Celsius. Converting into Kelvin, it will become 423 Kelvin. So this is your hot body. This is your hot body. On the other side, cold water, that is, you can take M2, mass is 100 grams. And now they have mentioned a temperature as 11 degrees Celsius. Converting into Kelvin, you get 284 Kelvin. So this is your cold body. You have mixed both. On mixing, the final temperature at T is identified as 20 degrees, so which is equal to 293 Kelvin. So this is the information you have. Now they are asking to find out the value of specific heat capacity for this. So you know that principle of calorimetry. What is the principle of calorimetry? That is nothing but heat lost by your metal is equal to heat gained by water, because cold water, so therefore it gains heat. So heat gained by water. Now substituting the formulae, we can write it as M1 C of metal delta T is equal to M2 CW delta T. So we can take it as 50 into this, we don't know. Delta T is 423 minus 293. That means what? This is higher temperature and equilibrium temperature is low, so you have to subtract this. Is equal to mass is 100 into, they have mentioned for water C is 4.2, and here it is 293 minus 284. So according to the principle of calorimetry. So finally on calculation we get Cm is 100 into 4.2 into 9 by 50 into 130. So answer you get it as 0.582 joule per gram per Kelvin. Hope everybody understood this. Next we are taking question number 10. So here they have taken water, on the other side they have taken copper. So it is mentioned the mass of water is 45 grams and the temperature of water is 50 degrees. Specific heat of water is identified as 4.2 joule per kg per Kelvin. Now for copper, mass of copper is 50 grams and temperature of copper is 18. So looking at the temperature we can immediately identify that this is a hot body and less temperature, therefore this is cold body. Next, specific heat capacity of copper is given as 0.39 joule per gram per Kelvin. Now the question is, if you are adding these two, the final temperature is T and you have to identify what is the final temperature. Hope you have understood this. So you all know that heat gained by copper is heat lost by water. One important formula we have, what is that? The final temperature T is identified as M1C1 T1 plus M2 C2 T2 divided by M1 C1 plus M2 C2. Right, so everybody, I think you are able to follow this. So here I have written all the values and here I have given you the formula. What we should do is just substitute the values. That is equal to 45 into 4.2 into 50 plus 50 into 0.39 into 18 divided by 45 into 4.2 plus 50 into 0.39. So I have calculated all these values and finally I got T is equal to 9801 divided by 208.5. So I have got a value of 47 degrees Celsius. So finally we can understand that after adding the copper with hot water, the temperature becomes 47 degrees Celsius. Next, question number 11. So here they have given the hot condition, that is water, both water only. So 200 grams, we can convert into kg, 0.2 kg. The other side mass M2 you take 400 grams, we can write it as 0.4 kg. We apply the same formula here. Now T1 is equal to 80 degrees and T2 is equal to 10 degrees. Looking at this we can understand that this is cold and here it is hot body. Now C value is given, for water it is same, so therefore both have same values. C is equal to 4200. Now once again they are asking us calculate the final temperature, so which is T. So I have given you the formula for the final temperature, that is T is equal to M1C1 T1 plus M2 C2 T2 divided by M1 C1 plus M2 C2. So just substitute the values here, 0.2 mass into 4200 C, temperature 80 plus 0.4 is the mass, specific heat capacity 4200, temperature 10 degrees divided by, so M1 C1 plus M2 C2. I have calculated this and I got values of 84,000 divided by 2520. So therefore final temperature is 33.3 degrees Celsius. Hope everybody understood this. Question number 12. Here again cold water is given, mass 600 gram, delta T is 15 degrees, hot body take it as M2 300 grams, temperature is 50 degrees. Looking at the temperature, we have identified this is cold water, on the other side this is hot water. So we know very well heat gained by cold water or cold body will be always equal to heat lost by hot body. Here it is hot water. If you write the formula, we can take it as M1C delta T1 is equal to M2C delta T2. Because C is same, cancel out C and substitute the other values. So we write mass 600 into 15 is equal to 300. You don't know this delta T2. We can take it like this. Send 300 to other side and we get delta T2 is equal to 600 into 15 divided by 300. So 2. Therefore delta T we can find it as 30 degrees Celsius. Now you imagine that final temperature is T. So you got a change in the temperature. Let final temperature of the mixture is equal to T. We know that 30 degrees is equal to 50 minus T. That is, this is change in temperature. Change in temperature is equal to final temperature, which is given, minus initial temperature. They are asking in the question what is the initial temperature, how much you have raised it. Right, now we can calculate it. So what we get on sending it to other side, T is equal to 50 minus 30, which is equal to 20. Hope you have understood up to this. Now if temperature is given and we got 20, they are telling the rise in the temperature of cold water. Right. So how much rise was there? They only told that it is 15 degrees cold water. So we substitute this 20 minus T is equal to 15 degrees. Right. So now what is this? Or you write T1. So 20 minus T1 is equal to this. So 15 T1. Therefore T1 is equal to 5 degrees Celsius, which is your initial temperature. So we have understood this. Now the last question, 13. They gave you mass 1 kg. Converting into gram, we get 1000 grams. C, specific heat capacity 4.2 joule per gram per Kelvin. Because they gave in gram, we took it in gram. Delta T is equal to final minus initial, we get 75 degrees. So apply the formula Q is equal to MC delta T. So to get Q, that is equal to mass 1000, specific heat capacity 4.2 into 75. So we get Q finally as 315 into 10 to the power of 3 joule. Right. So first we get heat energy. Next, we know that power is equal to 1.25 kilowatt, nothing but 1.25 into 10 to the power of 3 watt, and we calculated Q value as 315 into 10 to the power of 3 joule. Right. So they are asking find out the time. Substituting that, P is equal to Q by T. Power is 1.25 into 10 to the power of 3 is equal to 315 into 10 to the power of 3 divided by time. send it to other side, and we get time is equal to 315 into 10 power 3 divided by 1.25 into 10 power 3. This 2 gets cancelled out and you get 252 seconds. So finally we should take in minutes. So time is 4 minutes and 12 seconds. So this is your answer. So hope you have understood all the numericals in calorimetry. Thank you so much.